few years ago, a TV show, The West Wing, held a poll for imaginary presidential candidates. In the poll, 54% of the people said that they would have voted for Matt Santos, who was played by actor Jimmy Smits, whereas 38% favored the Republican candidate, played by Alan Alda. The poll was conducted online with a sample of 1,208 respondents, and the Zagby company screens the online respondents to try to ensure that they are representative of the population of adult Americans. Question A asks you to describe the relevant population and parameter. The population of interest here is all adult Americans who are familiar with these fictional candidates. The parameter we can call pi is the proportion of the population who would have supported Santos if they had been asked. Question B asks you to use technology to produce 90, 95%, and 99% confidence intervals for the population proportion favoring Santos. So for Santos, we had 54% of the 12,008 respondents. So in the test of significance calculator applet, we can put the 1208 in for the sample size and the 0.54 in as the sample proportion, and press confidence interval to get the 95% interval, change the confidence level to 90%, and change the confidence level to 99%. So here are our three confidence intervals, and question C asks you to comment on how these intervals compare. To find the midpoints, we just take the average of the two endpoints. We see that we get 0.54, the sample proportion, every time. To find the widths, we just take the difference between the endpoints, and we can see as expected the width gets bigger as you increase the confidence level. Question D asks whether these intervals suggest that more than half the population favored Santos. And since these intervals only contain values greater than 0.5, they do suggest that more than half the population favored Santos. The plausible values for the population proportion are always greater than 0.5. Question E asks you to state null and alternative hypotheses for testing whether or not the sample data provides strong evidence that more than half of the population favored Santos. So our null hypothesis would be that it is just half the population, or pi equals 0.5, and the alternative hypothesis would be this more than half the population, or pi greater than 0.5, were favoring Santos. So what can we say about the p-value for testing these hypotheses based on our earlier confidence intervals? Remember, 0.5 was not inside any of these intervals, but we want the one-sided p-value, so we could do 1 minus the confidence level, but then divide that by 2 to get the one-sided p-values. Question G asks you to describe what a type 1 error would mean and what a type 2 error would mean in this context, or of these hypotheses we just stated. So type 1 would be concluding that a majority are in favor of Santos, when really he was not favored by more than half the population. Type 2 would mean concluding Santos was not favored by more than half, when in truth he was. Would a test of significance in Part E have had more power if 55% of the population actually favored Santos, or if 52% of the population actually favored Santos? We're trying to test against the null hypothesis that 50% favors Santos. Because 55% is further away from 50%, that's going to have more power. If our true population proportion is even further away from what we hypothesize, it's going to be easier for us to detect that. Question E asks whether the sample proportion of 0.54 favoring Santos would be more impressive if the sample size were 10,000 or 100. And a sample proportion of 0.54 is going to be considered even more extreme, even more convincing evidence against a population proportion of 0.5 with the larger sample size, because we would expect less sample-to-sample variability, and we'd expect our sample proportions to be even closer to 0.5, so 0.54 is going to appear more extreme.